Hello friends, today we want to look at mensuration. We want to focus on three-dimensional shapes. We will take a couple of examples. Our first example, a toolbox of dimensions, a toolbox with a lid has dimensions 16 centimeters by 12 centimeters by 10 centimeters. Find A, the total surface area, and then find B, the volume of the toolbox. Alright, to do that, let's start by drawing our toolbox, so we can have a little sketch of our toolbox. This is a cuboid. It's a cuboid, and we are told it has dimensions 16 centimeters by 12 centimeters by 10 centimeters. So something like this. Alright. Now, to find the total surface area, let's call this TSA. We can first sketch. You know, there's a formula, but then you can also sketch the net and use the net to help you remember the formula. So we have our 6 faces, our 6 rectangular faces of our rectangle. So we'll see that we have length times breadth, and then we'll have length times the height, breadth times the height, and then we'll have another length times the height, and then the length times the breadth. So our TSA will be given by 2 into brackets LB plus 2LH plus 2BH. 2 into brackets LB plus LH plus BH. Okay, so we can take 16 to be our L, and then perhaps 10 to be our B. So our L will be 16, that's the longest side. Our B should be 10 centimeters, and our height will be 12 centimeters, okay? So our LB is going to be 16 times 10 plus LH 16 times 12 plus BH 10 times 12. Okay. So what do we have here? What is 16 times 10? That should be 160 plus 16 times 12. Sixteen times 12, 192 plus 10 times 12, 120. Now if we sum up everything, we should have 160 plus 192 plus 120. This will give us 472. Now multiply it by 2 to get 944 centimeters squared. This is an area, so we have centimeters squared. Let's look at the second part, B. We are to find the volume of the cuboid. Now the volume of a cuboid is given by L times B times H. So we have 16 times 10 times 12. What will that give us? 16 times 10 times 12. This should be 1,920 centimeters cubed. Volume is measured in cubic centimeters. Okay. All right, let's move on to another example. Let's consider a cone. This will be an example involving a cone. A right circular cone, has base radius 5 centimeters and height 12 centimeters. Calculate its A total surface area and then B volume. Total surface area and volume. All right. So again, we'll start by drawing our diagram. Right circular means it's upright. Okay. It's a cone. It has a base radius of 5 centimeters. It has a height of 12 centimeters. Now, to find its total surface area, we will have the curved surface. If we are to draw the net of our cone, it will look something like this. This is the curved surface area, plus the circular base. But we are not told that it has a circular base. So we are just going to focus on the curved surface area for the total surface area. And the formula is pi r L. All right. Let's assume that we are given pi to be 22/7 in our question. Most of the time, they will define pi for you, either 22/7 or 3.15. Okay. Now, to find our L, that's the slant height, that is over here, let's bring out a right angle triangle, where 12 is the height of the pyramid, the cone, 5 cm is the base radius, and then L will be the slant height. So that L will be given by the square root of 12 squared plus 5 squared. So if we are to find the square root of 12 squared plus 5 squared, what will that give us? It will give us 13 centimeters. So we can apply that for our total surface area, which in this case is the curved surface area. 22/7 times the radius 5 times 13. So we compute 22/7. You can go ahead and compute it with me. 22/7 times 5 times 13. And this should give us 204.2857 centimeters squared. Write your answer in 4 decimal places, and then you can approximate maybe to 2 decimal places. 204.29 centimeters squared. Good. Now what about the volume? The volume of a cone, we know volume of every pyramid is 1/3 base area times height. That is the general formula. 1/3 base area times height. So now in this case, what is our base area? Our base is a circle. So our base area will be the formula for finding the area of a circle, which is pi r squared, and times the height, which is h. So we are going to have 1/2 times 22/7 times 5 squared. And what is the height? Times 12. Go ahead and let's compute this together. Half times 22/7 times 5 squared times 12. What will this give us? We are getting 471.428 centimeters cubed. And then we can approximate it to 471.43 centimeters cubed. Volume is always in cubic units. So that is the second example. Now for our third example, we are going to look at what happens when a sector of a circle is cut out of a circle and the remaining sector is formed into a cone. What is the relationship between the radius of that circle and the cone and the radius of the cone? Okay, so let's take our third example. The diagram below shows a sector of a circle of radius 14 centimeters. The angle at the center is 270 degrees. The sector is folded to form a cone. The sector is folded to form a cone. Find A, the radius of the cone. The radius of the cone. And then B, the surface area of the cone. And then C, the volume of the cone. All right. So this is what we are told. We are told the diagram. So this is part of the question. We have a diagram here. And then we are given the angle at the sector to be 270 degrees. The radius of the sector is 14 centimeters. I forgot to add, we are told to take pi to be 22/7. All right. Now they are telling us that this was formed into a cone. Now when you are making a cone, you can just cut out a sector of a circle and then fold it up to form a cone. This cone will have a radius r, and then it will have a height of what? H. Now what is the relationship between this sector and the cone? First of all, we can see that the circumference or the length of arc of the length of arc of the sector, the length of arc of the sector is going to be the same as the what? The circumference of the circle. The length of arc of the sector is going to be the same as the circumference of the circle. And so, if we want to find, and then the radius of the circle is the same as the what? The slant height of the cone. The radius of the circle is the same as the slant height of the cone. So if we want to find the radius of the circle, it is simply going to be r, that's the radius of the cone. R is equal to theta over 360 times L. And in this case, our theta is 270. That's the angle at the sector. So our R is going to be 270 over 360 times what? Times 14. So when we compute this, 270, let's compute it together. 270 over 360 times 14. This will give us 10.5 centimeters. And that is the radius of the cone. So we found the radius of the cone. That is A. Now for B, the curved surface area, that is the same as the surface area of the cone, because it will only form the curved surface. We don't have the circular base. And that is our pi RL. We established that L is 14, the same as the radius of the cone. So this is going to be the same as 22/7 times the radius we found, 10.5 times 14. Let's compute it together. 22/7 times 10.5 times 14. And this will give us 462 centimeters squared. 462 centimeters squared. That is the surface area. For C, we are being asked to find the volume of the cone. we know is given by 1/3 pi r squared h. 1/3 pi r squared h. But we don't know h. So let's bring out the center of the cone, that right-angled triangle. So we are going to have a radius. We already found it to be 10.5. The slant height, we got it from the radius of the sector, and that was 14 centimeters. So we can find h using Pythagoras theorem. So this 14 is the hypotenuse. So we are going to have h is equal to 14 squared minus 10.5 squared. Now let's compute it together. 14 squared minus 10.5 squared. This should give us 9.2601 centimeters to 4 decimal places because we are going to reuse it. Let's not do a premature approximation. So let's use that in our formula. 1/3 pi r squared h, 1/3 times 22/7 times 10.5, that is our r squared, times h. H was found to be 9.2601. All right, let's compute that together. 1/3 times 22/7 times 10.5 squared times 9.2601. So you punch it into your calculator. What do you get? I think we had 1069.54155 centimeters cubed. So this is approximately 1069.54 centimeters cubed if we round it to 2 decimal places. And that is the volume of our